And the day before, we were looking at, and what we just did at the beginning of class here, we were looking at these things, right? Negative f of x and f of negative x. And those flipped it over the x or the y-axis. What number is in, like, this negative represents a number. What number does that represent? Negative 1, right? And same with this one. Okay? Now we're going to look at things if it's not negative 1. It could be a 2, a negative 2, a negative 5, 8, but it can be a fraction, 1/2. Okay? What does it do to the graph? So, here's our function. Square root of 4 minus x squared. Here's the graph here. We put a 3 in front of the f of x. Okay? What do you think that 3 does? Does that affect the x values or the y values?
Y, maybe Y only.
Okay. What does this number affect? X or y?
Y.
What does this number affect? It's in the same spot, right? Okay, it's in front of the function. So this will change the y values. The new equation will be y is equal to, you just multiply the equation by 3. So 3 times 4 minus square root of x squared. 3 times the square root of 4 minus x squared. That's what I'm trying to say. So, instead of me drawing it out, okay. Here's our graph. Okay. 4 minus, I did it twice just to show you when I change it. Okay. It's a semicircle. Okay. It's got x-intercepts of plus minus 2 and a y-intercept of 2 as well. We are putting a 3 in front of the whole thing. So if I put a 3 in front of it, what do you think is going to happen? It changed the y values. Boom, stretched them by a factor of 3. You just multiply all the y values by 3. That's all it did. This y value was 2 times 3 becomes 6. This one is, we'll just guess, say it's 1 times 3 becomes, or where's 3? Oh, that's not 1. There's 1 right there. Times 3 becomes 3. Okay? All you're doing is changing the y values by whatever that number is. If it's a 3, you multiply by 3. If it's, what's the next bit? If you go back to the page, or let me draw this quickly. So it didn't change the x value or the x-intercepts. Why did it not change the x-intercepts? It only affects the y, but those have y values. It's just 0. The y value is 0 at the x-intercepts, right? So let me write this. Okay, general sketch. It expands the graph by a factor of 3. X-intercepts are the same because y is equal to 0. And the y-intercept increased by a factor of 3. The short answer is multiply y values by 3. That's all you do. Yeah.
When it's not a 0 on the, when it's like with up, is it then multiplied with 3 too? So when the k isn't 0, then it's like 1.
Oh, so if it was like x squared plus 1 and you put a 3 in front of it, it goes to everything. Yeah, we're going to look at those things later on. So you mean like this, right? If you started with x squared plus 1 and I said do 3 f of x, yeah, you're going to get 3 Okay, so if we put a fraction in front, 1/2, what's it going to do? It should, yeah, it should just shrink it, right? So let's put a 0.5. We'll do 1/2. Oh my gosh. There you go. That would go away. You can see we went from the red, which is the original, to 1/2. It dropped the 2, the y-intercept, down to 1. Okay. So what did? We just multiplied all the y values by 0.5 or 1/2. That's all this value does, or all this number does. So graph shrunk. Again, x-intercepts stayed the same because they are 0. So this is I'm going to say compression. X-intercepts are the same. Y-intercept decreases by 1/2. Multiply y values by 1/2. Every y value on that graph gets multiplied by 1/2, so everything shrinks. Okay, are we all right? This is called an a value. Okay, when you put a number right in front of the function, we call it a. I mean, other books will use a different symbol. This book uses a, so we'll call it a. So if we put an a in front of it, it results in a horizontal or vertical stretch. Vertical. We call these stretches. When you're stretching something, you're multiplying it. Okay. A translation is when you're moving it left, right, up, down. Okay, but when you multiply it, you're stretching it. So what axis didn't change? The x-axis didn't change, right? I'm not too concerned about you saying it's a vertical stretch about the x-axis. This is just the notation or the language. The important part is by a factor of, what do I multiply by? A. Okay. Don't worry about that stuff. If a is greater than 1, does the graph get bigger or smaller? It's an expansion. If a is between 1 and 0, i.e., it's a fraction or a decimal, it's a compression. I'm not too worried about you saying expansion, compression. You can just say a vertical stretch by whatever a is. Okay? So if a is 1/2 and you say this is a vertical stretch by 1/2, we all understand you're multiplying by 1/2, the graph's going to get smaller. Okay? Or a vertical stretch by 5 means the graph's going to stretch out. Any questions about that? All right. You ready for B? B. B goes with the x. So B is like this. This is a B value. What's my B value here? -1, except now we're not going to use -1. We're going to use a different number, a whole number, or, well, it could be a fraction as well. So in this case, we have f of 4x. Same starting graph. I put that into the equation. I get 4 minus 4x all squared. What's 4x all squared? There you go. So I get 16x squared. This is my new function. What do you think the 4 is going to do? Affect the x's or the y's? The x values, right? Because it's right there with the x. And this affects the x values. So it's going to do something this way. Is it going to make it bigger? Or is it going to shrink it? I've heard a bit of both. Let's find out. So let's clear that. I'm hearing people think it's going to shrink. So here's our original graph. I'm going to put a 4 right there. What'd it do? It shrunk. The B value is the tricky part of this whole unit. Okay? Because when you put a whole number in there, a number greater than 1, the graph actually gets smaller. If you put a fraction in there, what's going to happen? It's going to get bigger. If I change this to, I don't know, what's a fraction? We'll do 0.5, 1 over 2. Whoops. 1 over 2. Look at that. If I put 1/2 in there, the graph gets bigger. It gets bigger by a factor of, just one sec. It gets bigger by a factor of what? 2. It went from -2 to +2. Okay? So the B value is the tricky one. A B value is the reverse, is the flip. Not just inside square roots. Any B value you put into a function. Flip. It's always flipped. I'll sum it up at the bottom, but yes. So if I put the 4 in, we went from x-intercepts of 2. You divide by 4, okay, or multiply by 1/4. They're going to go to half, so they don't. It's not really nice that they did this, but the graph looks like that. It gets boom. Okay. So we get a compression by 1 over 4. We multiplied all our x values by 1 over 4. X-intercepts change by a factor of 1 over 4, what I just said. I'm just going to put arrows down because it's the same thing. Did the y-intercept change?
No.
Why?
X value 0.
Because the x value is 0. Same, because x equals 0. Let's just say multiply x values by 1/4. So I didn't do 1/3, I did a half. But if I put a third in, what's going to happen to this graph here? Bigger by a factor of 3. Right? So all your x values, these are at 2 and -2 times 3 is going to go to 6 and -6. So I'll say horizontal stretch by 3. Essentially, multiply x values by 3. That's what that means. X-intercepts, yeah, that's the same thing. So I'm not going to write that. And the y-intercept stayed the same. Oh, for this one? Yeah. So it's going to be y is equal to 4 minus 1/3 x all squared in square root. You square a third, you get a 9th. So it's that. Merci. Thank you. So that's the equation. Okay? So, to sum this up, if your b value is, what does b value do? Let's talk about that. Changes the x. So we said it was a vertical stretch for the a, so the b is going to be a horizontal stretch about the y-axis. I don't really care about that part. This is the key factor here, this little thing at the bottom. By a factor of 1 over b. Whatever your b value is, take the reciprocal of it, or flip it. That is what you multiply by. Okay? Yes, b value will always be in front of the x. Multiply by 1 over b. So for example, if I said f of 2/3 x, is that going to be an expansion or compression? It's going to be an expansion, right? Because what do you multiply by? So your b value is 2 over 3. The b value is the number in there, but what you multiply by is 1 over that number. So you just flip it. Multiply by 3 over 2. Okay? So you would just say, if I said, what does this do? All I would need you to say is, just say an HS, horizontal stretch, by 3 over 2. You don't have to say an expansion or compression. You can if you want, but if you just said it's a horizontal stretch by 3 over 2, I'm good. Because that means you just multiply by 3 over 2, and you're going to get the expansion. Is that okay? The B's are a little weird, but once you get the hang of it, you should be okay. So let's try number 1, A, B, C, and D. So we're on page 101? 101. All right. Okay, this is a polynomial graph. We study polynomial graphs later on, so you'll learn how to graph this. They're actually straightforward. This is the equation, okay? But I will just give you the graph right now. We do this to it. Is this an A or a B value? A. So my A, I guess we should write the equation, is -3 times this whole thing. I'm not going to multiply it in because I don't really care. They say use a graphing calculator to sketch. No, we're better than that. We're just going to sketch. Okay. So my A value is -3. All right, we haven't talked about the negatives when it's coupled with a number greater than 1. Yesterday when we did negatives, a negative A value, what did it do? It flipped it over the x-axis, right? So if you have a negative here, it does the same thing. So 2 things happen with this. 1, you get a flip over the x-axis. And 2, what does the 3 do? You multiply it by 3. It's a vertical stretch by 3. Vs by 3. You don't have to do these separately. You can do them at the same time. What do? You multiply all your y values by -3. That's the, I won't say shortcut, but that's the quick way to do it. So that's what we're going to do. Okay? We're going to multiply all our y values by 3. So we can mark the points that don't change. What points don't change? The x-intercepts. that one, and that one. Those are going to stay the same. Don't multiply every point, okay? We know the graph is going to, this part is going to flip up, and this part is going to flip down, and there's going to be a stretch. Just pick the key points. I would say the top of the curve, the bottom of the curve, and maybe 1 point here and 1 point there. That's all you need. And then just connect it in a smooth line, okay? So pick easy points. Don't pick like 1.34. Guess where that is? Just pick nice easy points. I'm going to pick this because it's at -4. If I multiply -4 times -3, what do I get? 12. So that point right there moves right up to 12. I'll do it in a different color, purple. This maximum here is at 8. Even though it looks like it goes above it, we'll just say it's at 8. I multiply it by -3, I get -24. So you go, boom. Conveniently, they have a graph that goes to -24. So I'm going to connect these right now. So it has to go through that. It has to go through the x-intercept. Has to come around here. That purple point right here is at 6 times -3 is going to go to -18. So the graph turns. Has to go through this x-intercept. This minimum right here is at -4 times -3 moves up to 12. And then it has to go through that x-intercept, and I'm just going to draw it like that. So there's your graph. Actually, it doesn't look very good. I'll put it in red.
Do we have to sketch it all the time?
Sorry?
Do we have to sketch it all the time?
On what? Oh, only if I asked you.
Okay.
Well, you only do what I asked you to.
Is there a reason why like it's more rounded on this one and then before it was more like jagged?
You mean these things?
Yeah.
Yeah, it's just that's what a polynomial graph looks like. Yeah. And you can see my graph is horrendous. I don't care what your graph looks like. What I'm going to look for is the key points. Like, did you get this to here? Did this go to here? Did the x-intercept stay the same? And so you can see we flipped it. This bit flipped down. This bit flipped up, and we stretched it vertically. Okay. Is that okay? Yeah. All right. We're gonna flip the page, and we're gonna do b value. All right. We'll just write where this -1/3 goes. So first of all, what do you think the 1/3 is going to do?
Multiply it all by -3.
You're going to multiply all the x values by -3. So that's going to do a horizontal stretch, okay? And we're going to flip it over the y-axis, right? So two things are going to happen. We're going to get a flip over y-axis and a HS horizontal stretch by 3. Again, the shortcut is multiply x values by -3. All right. What point doesn't change? Y-intercept. So this point right here is not going to change. Again, pick the nice easy points. So the easy points to me, because it's only the x values that are changing, would be your x-intercepts to move and the peaks and the valleys. Okay? So this -2, I multiply it by -3, moves to +6. This peak, okay, it's not exactly at 1, but I'm just going to pretend that it's at 1. Right there. Okay? I know the peak's right there, but I'm just going to pretend it's at -1, just to make it easier. Times -3 goes to +3. I'm going to connect what I have so far. So the graph comes up, peaks, has to go through my y-intercept. The next point is going to be this 1 times -3 goes to -3. Drops down. The minimum, which I'm going to call it 2 again, times -3 goes to -6. So that's where my min is going to be over here. And then this x-intercept at 3 moves to -9. And it just keeps going up. And that's your graph. So we flipped it, boom, and pulled it apart. Yeah.
Could you also, first of all, make it positive and then multiply it by 3 to do it at the same time?
Like multiply them by -1 essentially. Is that what you're saying? Like make this positive.
Flip it first and then multiply.
Yeah, you can do it. Yeah, you can do it in 2 steps if you want. If that makes more sense to you, then do it that way. Anything else?
So you just took the x values and multiplied them.
You take all your x values. By all, I mean take the key ones. But essentially, if you're actually plotting this, you could multiply all your x values by -3, plot the points, graph it. That's all it does. Okay? All right. Okay. We're okay with that? All right. We're going to page 114. No, hang on. Forgot. Different book. Come back to that. Page 104, please. 104. Okay, so it's kind of what we did earlier on question number 1. They want us to write the image. So our new equation right now we're just dealing with A and B, okay? So we're just dealing with this, AF of BX. We're not worried about this equation. H and K we've kind of put off to the side right now. They will come back, okay? But right now we're just dealing with A and B. We just need to fill in what A and B are. So we're doing a horizontal stretch by a factor of 6. Is that an A or a B value? That's a B. It's a factor of 6. So what is my B value? 1/6. If I don't say anything about the vertical, then your A is equal to 1. Okay? Because if you it's not 0, because if you multiplied by 0, what happens? It explodes or goes away. Everything, it all gets messed up, right? So we go y is equal to f of 1/6 x. All right, vertical stretch by a factor of a 5th. A or B? A. Do we flip A? No, we do not. So it's y is equal to 1/5 f of x. A reflection in the x-axis. As soon as you see the word reflection or flip, what does that mean? It's going to be a negative value, right? And a vertical stretch about the x-axis by a factor of 3. Okay, do we have an A or a B here? Oh, is it an A and B? It's just A, right? Because the x-axis, here's the x, here's the y. If we reflect over there, that's an A value, right? Because we're changing the y's. So this is an A value of what? -3. So our equation would be -3 f of x. Horizontal stretch by a factor of a half and a vertical stretch by a factor of a quarter. What's my A? 1/4. What's my b? 2, or 2 over 1 if you want. So the equation is we have 2 there. We have 1/4 f of 2x. Are we okay? We're doing good? No is not okay. All right. Last bit for today. All right. Page 105, please. Right at the top. What if they wrote this? 3y is equal to f of x. What's wrong with that right now?
The a value is 1/3.
Yeah, because we don't want a y value. We don't want 3 y's, right? So you divide off the 3 on each side. You'll get this. So there's 2 ways to look at this. You can write it that way, f of x over 3, but that is the same as 1/3 f of x. Okay? So what are we doing to the graph then? Vertical or horizontal? By? Vertical stretch by 1/3. Sorry? Oh, sorry, my bracket is less than desirable. Okay. One more question. Can I flip down at the bottom? All right, we're not doing this. We're going to do the graph at the bottom. Here we go. Last bit for today. So, here's our graph. We do this. Sketch it. I'll put the answer up in a sec. F of negative 2x, is that an A or a B? By a factor of? 1/2, and the negative does? A flip. What's the shortcut? Times it by?
1/2.
Who said negative 1/2? Multiply by negative 1/2, right? That's the trick. Your B factor here. So your B is negative 2, which causes a flip over what axis? The y-axis. And what? Horizontal stretch by a half. Okay. The negative causes the flip. The stretch is by a factor of a half. But the shortcut or the quick way is just multiply x values by negative 1/2. All right. You do that, and I will do it, and we'll see if we get the same graph. Yours will probably be right. And if it's not nice numbers, just guesstimate. We got it? Come on, I did it already. Let's go. Ready? Oh my gosh, peoples. Remember, you're just changing the x values.
Oh, you need to chill out here.
Okay, I'll drink my tea. Sorry. You done yet?
Hang on, now I'm done. Nope, not done. Now I'm done, Baldwin. Not even close to your button.
It's like 6 points.
Just do it. Just do it. Do it.
Is that it?
Yeah. Oh.
What the? Look, we went like this. We took it this way. We went boom, and we went. Just take this. -3 times -1/2 becomes +3. -4 times -1/2 becomes +2. That stays the same. That's a 4 times -1/2 becomes -2. -5, this is the messed up one, times -1/2 is -2.5 or 5 halves. I just guessed it there. And -6 times -1/2 is -3. Boom, 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 boom. Yes? No? Maybe so? All right, here's your questions. Finish number 1. And then you're going to do, I change this every year. I don't know why I just don't keep the same. You're going to do 2. So 1, 2. That's 5. Oh, you definitely got to do 5. And 7. 1, 2, 5, 7, please. That'll bring us up to the end of class.